Hello everyone. So today we will continue on the section 2, the definite integral, definition of the definite integral. And we already discussed the definition of the integral and introduced one theory, use the right endpoint to evaluate the definite integral. And also we work on some examples with the Riemann sum if we specify the number of n, the number of rectangles, right? And we already understand the net area. The area above x-axis is positive. The area below the x-axis, that is the net area. Now let's look at some special shapes for the area we are going to work out. Okay, like the first one. First, what is the function here? How can we understand the area of this shaded region? How can we understand part A? So this one will be the area under the function. What is the function here? The function should be fx equals x, right? It's y equals x. It's y equals x. The area of this region S, we still call region S. This region S is formed under the function y equals x. Y equals x gives a straight line, right? It's a simple straight line. And then the area of the region S is the area under the straight line, the function fx equals x from a to b, right? So it's the same. We can represent this one as a definite integral from a to b, lower to upper limit, and fx dx, right? Don't forget the dx, and this dx indicate we use the x as an independent variable, and we know that it doesn't matter you write ft dt, fr dr, it doesn't matter, right? So here, what is my function? What is my function actually? My function is x dx, right? My function is x. Now that is the definite integral we used to denote the area. Now, by the way, with our high school knowledge, what is the shape of this S? What is the shape of this S? This region S? That is the trapezoid, right? Actually, it's a trapezoid. Now, how can we evaluate the area for a trapezoid like this one with a 90-degree angle? So should it be the short length plus the longer length over 2 times the height. What is the height? What is the height for this trapezoid? B minus A, right? B minus A. If you work out the formula, the area formula for a trapezoid, the short side plus the longer side over 2 times the height. What is this one? 1/2 A plus B is the same as B plus A. 1/2 B plus A times B minus A. What is this one? What is this one? B plus A times B minus A. 1/2 B squared minus A squared. Right? Use the algebra formula. So what is the area for this one? Of course, it's this one. And especially, what happened when A is 0? What happened especially when A is 0? For example, if my A is 0 for this case, especially, so that becomes 0 to B, right? Of course, here B is the positive number, okay? B is a positive number. What happened? which means this part is also shaded. Starting from the origin point, the whole triangle will be shaded, right? The whole triangle will be shaded. What is the area when A equals 0 especially? 1/2 b squared, right? 1/2 b squared. That case, what is the shape of this region is? It's a triangle if we shaded this part, right? If we shaded this part. Let me change into a color. Change into what? Into blue. So this one, okay? This one, 1/2 b squared actually means we let a equal to 0 and we shaded this part. Make sense? So that is 1/2 b squared. Of course, here is b. This length is b. This length is b. What is the area for this triangle? 1/2 b squared, right? So we start to know the definite integral represents the area, but we can also combine it with the area we started before, right? Some area of special shapes, some formula about the area we know. Now, how about this one? This one is still the straight line. The function is fx equals x. This one. This is the first one. So it's the same function for those three graphs, okay? How about the second one? Of course, it's again the trapezoid, but in red color. This time, this region is below x-axis. Of course, here the area gives a positive number. How about the second one? Since this region is below x-axis, actually it will be negative, right? This time it will be negative. The formula is again the same. Actually, it's still from A to B to find the area, okay? To find the area, dx and A to B. What is my function? It's again x dx, right? And actually it's again this length, okay? This length and this length. You can do in this way, okay? You can do in this way. Actually, it's the area of this one. It's the area again, but you put a minus, okay? You put a minus. But this time, okay? Actually, this time, if you put b squared and a squared, which number is larger? Be careful, these a and b, they are negative numbers. If you put a square, of course a square will be larger than b square, right? So actually it equals this one. But since a square is greater than b square, so this one, the sign for this one should be, it's a negative area, right? It's a negative area because a squared is greater than b squared. It's the same, okay? Same. Just evaluate the area of the trapezoid. And then number three. So for this one, it's again the same interpretation. The area denotes the area can be interpreted as the area between a and b under the function fx, right? Still from a to b, but the difference from the first and second case is a is a negative number, b is a positive number. So the area we evaluated using the definite integral is the net area. And of course here, the red part will be larger than the blue part. So actually it's minus finally, right? The net area gives the negative one actually. But the former the former, again, it's the same, okay? It's the same. And here, if you're comparing the square, a square with b square, which one is larger? Of course, a square is larger. That's why you still have the negative number, which shows net area in this third case, right? Net area, which gives a negative number. So for those different cases, okay, that means you can choose different A and B to evaluate the area from different part, right? So that is someone asked me the question again. We said the definite integral is the number, but is it depend on lower and upper limit A and B? Of course, it depends on the lower and upper limit. In those three cases, we use the function fx equals x, but we choose different lower and upper limit. For the first case, A and B are both positive, right? Are both positive. So this area, this one is a positive number, of course, no problem. Okay, no problem. Positive. And the second case is when the lower and upper limit are both negative numbers, okay? And we know this region is below x-axis. Of course, the area will give the negative one. And in the third case, a is a negative number. The lower bound in the formula, in the definite integral, is the negative number, and b is positive number. But we know that the absolute value of a is greater than b. Okay? This length is greater than b. And from the graph, it's easy to tell the red part area is greater than the blue part. Of course, the net area will give the negative number. Okay? So from those three graphs, as A and B changes, the both lower and upper limit change, of course the area are different, right? So this gives a number, the definite integral gives a number, but it depends on the lower and upper limit, also depends on the function, right? Also depends on the function. So we can read some explanation for those three graphs here. Now, this is the one I'm talking about. Okay, this is the case I'm talking about. Here it's also the A to B. Fx is equals x. But here, especially my A is 0, right? Starting from 0. Especially case, my A is 0. What is the area for this triangle? Of course, it's 1/2 b squared, because a squared equal to 0. And of course, this is b. This is b. With the formula of a triangle, it's 1/2 b squared. No problem, right? So if the area, if the region is some shapes we're familiar with, like a rectangle, square, the triangle or trapezoid. Then those stuff we can combine with all the area formula, but it's still the definite integral can represent the area, right? So that is the triangle. Okay, so that is the one we work out. Okay, that is the one we work out. And usually when we write the lower limit, the a should be less than b. Lower limit should be less than the upper limit. This is the case we discussed before, and when our function fx is x, and it's easy, just a straight line, right? Just a straight line. So it will be 1/2 b squared minus a squared. But it might give a negative number with different choice of the lower and upper bound, right? Upper limit. Now let's try to understand what is number 2 and number 3 means. Okay, what is the function here for the number 2? For number 2, what is the function here? Comparing with the standard expression, from a to b, fx dx. Now my function fx is a constant c. What does this mean? We mentioned this function is a constant. What is a graph? What is the graph for function if it's a constant? Horizontal line, right? Horizontal line. So this is x or y. Fx equals c, which means it can be negative, okay? It can be negative. Here is the case I use C as a positive number. So it's C here. It's always a horizontal line, right? It's always a horizontal line. So for example, if I choose A and B here, what is the shape of the region S? If I choose A to B, find the area, evaluated the area under the function fx equals C from A to B. What is the area of this one? Of course, this is a rectangle. What is the length? What is the width? Width is B minus A, right? B minus A. What is the height? C, of course, right? So that is the area of rectangle actually. So that is height is C. Then the width should be B minus A. Here, from here we can tell usually B, the upper limit is greater than lower limit A, right? So it's the area of rectangle. So especially the second case, when the function is a constant, then the area is C times B minus A. And it doesn't matter when your C is a negative number, okay? It doesn't matter, okay? It doesn't matter when your C is a negative number. If this is C from A to B, from A to B, here is A, here is B, but this rectangle is below x-axis. So what is the sign for this term? C times B minus A. Negative, right? This area is negative. This is orange. This is 0. Because here C is a negative number. B minus A is still positive, right? Because B is greater than. And it doesn't matter if your A is negative, your B is positive. That still means a rectangle, right? Still means a rectangle. It still denotes this definite integral still denotes the net area of a rectangle, okay? The net area of a rectangle. So that is the second case, especially when the function is a constant. Third one, what is the function? Fx. Comparing with the standard expression. Of course, it's x squared, okay? What is the x squared, the situation we discussed? That is the first example we talk about in chapter 4, right? X squared, of course, it's just a parabola. Not very good, not very good. So this is a parabola, right? This is a parabola. And if we have the lower and upper limit, okay, we are not going to strictly understand this formula, but let's just double check the example we did when A is 0, when B is 1, right? We discussed the example, the area under the parabola from 0 to 1. Can you remember the answer? What is the area? Can you remember the answer? And also we proved that. What is the answer? So this area, the area of this region can be represented as from 0 to 1 fx dx. How can we get the answer? This is the case when b is 1 cube is 1/3, minus when a is 0, this term becomes 0, 1/3. The area of this region gives 1/3, and we already proved before, right? We already proved before. So that is some special case when we know the function and we can figure out the area, okay? Still, the definite integral means the area, and in this, it's an easy way if we know the shape of the region. But like this one, we cannot use any rectangle, triangle, trapezoid formula to work out it, right? This is a new formula, and we will understand this one later when we know how to find the how to work out the integral, okay? The integral. Now, let's evaluate example 3. Let's evaluate the following integrals by interpreting in each terms of area. We are going to discuss A, okay? I will let you think about part B. So now here, for A, what is, for this part A question, what is my lower and upper limit for this definite integral? A is 0, right? B is 1. What is my function here? My function is under the root 1 minus x squared, right? And here we solve part A, okay? Part A. So here looks like under the root 1 minus x squared. We are not familiar with this function, but let's work out, okay? Let's work out. If we let y equal to this one, looks like not some simple function we did before. If we let y equals this thing, and then how about y squared? Y squared equals 1 minus x squared. Then we shift the x to one side, put the constant in another side. We shift the x squared to the left side, then we get this one. What is the shape of this one? What does this formula mean? What is the shape of this equation? It's a circle, right? It's a circle. Center, okay? A circle. Actually, this is a circle. With center. Where is the center? 0, 0, right? With the center 0, 0. And the radius, what is the radius? The right side, the r squared gives the radius, with radius r equals 1, right? With the radius r equals 1. How can we draw this one? Just a circle on the x or y plane with the radius 1. It's not easy to draw a circle, okay? Okay, almost perfect, I guess. So this is minus 1, this is 1, this is 1, minus 1, this is 1. Okay, I'm satisfied with the circle I drew here, okay? So here, this is the circle, okay? This is a circle with the center 0, 0 and the radius 1. Now, what is the y? What is the y we choose? Let me use a different color, okay? So here, this function, of course, if you use a vertical line test, it's not a function, right? But we can choose two parts. Here, we take the positive part of y. We have two parts for y. Y above x-axis, this is positive value for y. Below the x-axis, that is the negative value for y. So here for y, we can take the half circle here, which gives the positive value for y. Like that, right? Now this is y. This is the region for the under the root 1 minus x squared. So this part in blue color, this shaded region in blue color is the region we are going to find. Now, how can we understand this definite integral? So this one actually means the area of the region as from where? From 0 to 1, right? So under this curve, this is the curve for root 1 minus x squared, right? Under the root 1 minus x squared, this is my function. This shows my function here. This positive part above x part. Now, this part is from minus 1 to 1. Then this one should be from 0 to 1. So should be the region here. So This one means the area under the function curve. Y equals under the curve. Fx equals, it also means y, under the curve from 0 to 1, right? From 0 to 1, which is the area I shaded in red color here. Okay, from 0 to 1, from 0 to 1, right? What is the area of this? This is a quarter of a circle, right? By the way, what is the area of the whole circle with the radius r equals 1? Pi r squared, which gives pi. How about the area of a quarter of the circle? 1/2, 1/4, right? 1/4 pi. Without doing any, we understand this area denotes 1/4 of the circle's area, which is 1/4 pi r squared. My r is 1. Make sense? So this one denotes the area under the curve from 0 to 1. Now, can you work out this one? From -1 to 1. How can we understand this one? This is the area under the curve from -1 to 1. What is the shape? Half circle, right? It's a half circle actually. What is the area for the half circle? 1/2 pi r squared. R is 1, so it's 1/2 pi. And here we don't need to worry about the sign because this part is all positive, right? It's all positive number. The area evaluated should be a positive number. It's all above x axis, right? So that is how we understand the definite area, a definite integral as the area, and it can combine with some old knowledge when we know some area formula, right? Trapezoid, triangle, the rectangle, and the circle, some familiar old formulas, right? Now we are going to talk about the last part, the properties of the definite integral for the section 2. Now let's take a 5 minutes break, okay? Take a 5 minutes break, then we come back.